Hello everyone. Today we'll be doing questions based on integration for the Gujcet. I've taken up some questions from the previous Gujcet papers and some other questions we'll consider. Let's begin with the first one. Okay, question 1 is say 0 to 13 e raised to cube root of 2x plus 1. So because it is cube root, let us substitute 2x plus 1 as t cube. So the derivative, differentiating on both the side, we have that means dx is equal to 3 by 2 t square dt. Also in case because it is a definite integration, let us find the limits that when x is equal to 0, then 2x plus 1 will be 2 into 0 plus 1, that is 1. That's the value of t cube. So t is going to be 1, cube root of 1. When x is 13, 2x plus 1 is, what is 2x plus 1? 27. Put 13. So what's the value of t? Taking cube root of 27, it is 3. So now our limits will change to, lower limit is 1 and the upper limit is 3 e raised to t, because 2x plus 1 is t cube. So the cube root of 2x plus 1 will be cube root of t cube, that's t. And what is dx? 3 by 2 t square dt. So we'll put 3 by 2 outside because it's constant, and integrate t square e raised to t dt. That is u into v integration. Integration uv dx is u integration v dx minus u dash integration v dx, and again integration of this. So here my u is going to be t square and v will be e raised to t. So 3 by 2. Let's integrate this t square e raised to t minus, as you see it is u dash 2t integration of e raised to t. After integrating, once again we have t e raised to t. We will have to integrate this once again with the formula uv of integration. That's integration by parts. So 2 here outside. Now t e raised to t, same formula, t integration e raised to t dt minus derivative of t is 1 into integration of e raised to t. So since most of the students are well equipped with this formula by now, this steps will go very faster. I'm writing all the steps, but you can skip a few. So this becomes t e raised to t, integration of e raised to t, minus minus will become plus, and again the same. Now put the limit. So it is 3 by 2, t square is 9, e cube minus 6 e cube plus 2 e cube. We are putting the upper limit for 3. 40, that is 3. Now the lower limit. E raised to 1, 1 into e raised to 1 minus 2e plus 2e. After putting the value as 1. So for lower limit we know upper limit minus lower limit. So I put a bracket for that. You simplify this, see how much it is. It's 5e cube minus e. Okay, that's the answer. The options were, we will write it down. So let's select which one of this is the correct option. 2e by 3, 1 minus 5e square. So obviously this is not. 2e by 3, 5e square minus 1. And then option C is 3e by 2, 1 minus 5e square. And option D is 3e by 2, 5e square minus 1. So I think this is the one, because if you take e common over here, that's what we get, 5e square minus 1. This is how we have done the first question. Now let's go to the second question. It is e raised to e raised to x log x to the base e plus log x upon okay, let's take the second question now. It is integration x minus 1 the whole square upon x square plus 1 the whole square dx. Okay, so here we have the second question, and let's see how to solve this, because it is x minus 1 the whole square upon x square plus 1 the whole square. I think the first thing we can do is expand this, since both of them have the same degree, x square and x square. It can be simplified easily. Also, when you expand this, you notice that x square plus 1 is the term in the denominator, so group it in such a way, and obviously we will separate it because it's x square plus 1 here, and in the denominator also the same thing. So x square plus 1 minus 2x upon x square plus 1 the whole square dx. So the first term becomes 1 upon x square plus 1. See, now this one you may not integrate also, because that's tan inverse x, which is already given in the question. We are supposed to find fx. So we need to concentrate on this. So when you are writing your paper, or when you are solving for the entrance examinations, you can skip that part. So this becomes, now I'm writing, this is tan inverse x, and this is of the form integration f dash upon fx the whole square. You can take this as a formula. This is can be written as fx the whole raised to minus 2 into f dash x, and that is like x raised to n formula. So it is fx raised to minus 2 plus 1 upon minus 2 plus 1, and it's the same thing here. X square plus 1 is the function, its derivative is 2x. So instead of substituting this as t and then writing the value, we can directly use this. So it becomes minus, or rather it is minus 1 upon. We'll directly put it as plus 1. Minus of minus will become plus 1 upon the function, which is x square plus 1. And of course, so plus c is there. So that means our answer is B. Okay, so let's move on to the next. So let's start with the third question. It is integration root cot x upon sin x cos x dx, and these are the options. So since we have sin x cos x, we can, otherwise because cot x is there, we will rather divide the denominator here, because we have cos, we'll divide with sin x and multiply with sine, so this makes sine square x. We did this for two reasons, like we have cot x and 1 upon cos x will become cos square x. That's one thing, and denominator also got cot x plus 1 became cot x. So that will finally turn out to be cot x raised to minus half into cos x square x dx. So like the previous question, we have here again f dash x into fx raised to n dx, which is fx raised to n plus 1 upon n plus 1. In the previous sum, we used the same formula, but there we had written minus 1 because we had minus 1 there. This is the general formula. So what is our n here now? But the derivative of cot x is minus cos x square. So what we can do is multiply by minus and again with minus. So this becomes cot x raised to minus half plus 1 upon minus half plus 1. And that makes it half. So it is minus of 2 root cot x. Yes, that's it. Our answer is T. Okay, we go to the next now, fourth. So we are with the fourth question here. It's limit pi to 3 pi by 2. In out of the many properties of integration, we have one of the property where we can take, if it is a to b limit, we can use f of a plus b minus x dx. Okay, both of these functions are same. So instead of fx, we can write f of a plus b minus x. So let's check, since we have pi plus 3 pi by 2, which is 5 pi by 2, we'll be using this. So let's use it. Instead of x now, a plus b is 5 pi by 2. So wherever there is x, I will write 5 pi by 2 minus x minus again x square. So 5 pi by 2 minus x the whole square, close the bracket, cos 2 into 5 pi by 2 minus x. So the whole integral function becomes this kind. And from the first bracket, we have 5 pi by 2 minus x common. So I'm going to put that common. What else is left? First term 5 pi by 2 and second term minus of 5 pi by 2 minus x. So it becomes minus of 5 pi by 2 minus minus plus x. And this is cos of 5 pi minus 2x. Okay. So that this is integration I. Let's name it here. So this is also I. So this becomes pi to 3 pi by 2, 5 pi by 2 minus x, 5 pi by 2, 5 pi by 2 cancel, x cos, now it is 5 pi minus 2x. That means it is in the second quadrant, which is negative. So let's put the minus here. Okay, so it is similar. If we put this x inside, it is 5 pi by 2 minus x minus, 5 pi by 2 x minus x square into cos 2x. Same integral value it is. I is equal to minus I, or rather 2i is 0. I is equal to 0. So the integral value for this function is 0. Let's go to the next. So here we are with the fifth question, and as you can see, this is a geometric progression, the ratio being the same, and it is an infinite geometric progression. The formula for infinite GP summation is this, and here the first term is cos x, the ratio is second term upon first term, which is minus cos x. So Sn becomes cos x upon 1 plus cos x, and that's our function fx. So we'll be using that here. Instead of fx dx, now we will take cos x upon 1 plus cos x dx. Now whenever we have 1 plus cos x, 1 minus cos x, or sine term in there, you will have to multiply with the opposite sign. If 1 plus cos x is there, multiply with 1 minus cos x, divide with 1 minus cos x. Or else, because here the angle is in terms of x by 2, we will apply the formula of 1 plus cos x, which is 2 cos square x by 2. Since we have written here x by 2, numerator also we will write 2 cos square minus 1. That's the formula of cos x. Split the term, separate it out, upon 2 cos square x by 2 minus 1 upon 2 cos square x by 2. Dx. So 2 cos square will get cancelled. Here it is 1. Over here we have half. 1 upon cos square is sec square x by 2. Now what's the integration of 1? X. Half as it is. Integration of sec square is tan x by 2. But as we see, this is x by 2 and here we have x. So differentiate x by 2 in the denominator. And that makes it x minus tan x by 2 plus c. And that's option D. Okay, the question 6 here doesn't have, it's a log x question which is not integrable as such. You need like log x into 1 or something. And this is 7 plus log x upon again a log x term. So the first thing we do is we substitute log x as t. Or rather, the base being e, we can also write e raised to t is equal to x. So that the derivative becomes e raised to t dt is dx. So this substitutions will go into the integration. It will become 7 plus t upon 8 plus t the whole square into e raised to t dt. Now since we have 8 plus t in the denominator, let us adjust the numerator, add 1 and subtract 1. Finally it is 7 plus t, which we have written as 8 plus t minus 1. And if we separate this, this is 1 upon 8 plus t and minus 1 upon 8 plus t the whole square. So this is a kind of question wherein we have a raised to x integration fx. Okay. Yeah, we'll take it like this. Integration e raised to x into fx plus f dash x dx. Function and its derivative. Then the answer is e raised to x fx plus c. So over here if you observe, 8 plus t is a function. 1 upon 8 plus t is a function. You can say it is ft. And if we differentiate this, it is minus 1 upon, and then we differentiate 8 plus t again, but that's 1. So this is a dash t. So our answer will be e raised to t into the function which is 1 upon this. And we put back the values. What is e raised to t? X. And t is log x. So our answer will be x upon 8 plus log x. That's option A. Okay. So this is an important property of or formula for integration. Okay, let's go on to the next one. Okay, so we have question 7 here. And as we see it is x plus root x. Whenever we have root, cube root term, it's better to think of taking it as t, substituting as t or t square. So we are going to substitute it here as t square. So that we'll get rid of the square root. If it would be cube root of x, we would have taken t cube. Now let's find what is the derivative. 2t dt it is. And once again, because it is a integral question with limits, let's change the limits. When x is 0, put 0 here. 0 is t square, or rather t is equal to 0, taking square root. And if x is 1, then 1 is equal to t square. That means t is 1, because if the lower limit is 0, I want a value bigger than 0. So it should be 1. It cannot be minus 1. Generally we do that. That when we take square root, we write t is plus minus 1, but over here it's going to be 1. So let's take that. Our limit becomes 0 to 1. Again, it's remaining same. What is our dx value? It is 2t dt. I'll write here. What's x? T square. So root x will be t. And that's very nice. We have t common. Will get cancelled with the numerator term. And integration of 1 upon t plus 1 is 1 upon x time, which is log modulus. So we'll write log modulus t plus 1. Of course, we have to differentiate t plus 1 in the denominator, but that's 1. So put the upper limit, log 2, and the lower limit, log 1. And that makes it as 2 log 2. Log 1 is 0. Now that is not one of the option, but we know that this 2 can be taken in the exponent here. That's a property of logarithm, that n log x is equal to log x raised to n. And so that comes out to be log 4. That's option C for us. Okay, well, let's move on to the next. That's the 8th question. Yeah, so here we are with the 8th question, and as you can see, this is a similar question. We have taken up a similar question, but that was root cortex. Now, since we have root 10x, we need to divide the denominator with cos. So we'll divide the denominator with cos x, and if we are dividing with cos x, we have to multiply with cos x, and because of this cos x, that becomes cos square now. Well, that's so nice. It is root 10x upon sine upon cos is tan x. And what is 1 upon cos square? It's sec square x. Let's simplify this before we solve it. This is root 10x upon tan x, that is tan x raised to minus half. Because this will get cancelled, in denominator we will get root tan x. So back to the kind of question or the kind of formula which we took, which was fx raised to n into f dash x. So when we have this, it is fx raised to n plus 1 upon n plus 1. Of course, plus c is there. So here it becomes tan x raised to half upon half. Because this is the function and this is the derivative. So minus half plus 1 will be half. So 2 root tan x it is. 2 root tan x. Option A. Okay. Let's go to the 9th. So in here it is limits 2 to k, wherein we have to find k. The integral value is given. Simple integration. Let's take this. 2 will be outside x dx plus 2 to k of 1 dx. The value is 6. So integration of x is x square by 2. Integration of 1 is x. That is 2k square upon 4. And what is the value here? Lower limit 2. So 2 square. Which is, okay, this is not 4, it is 2. It is 2 over here. And this is also 2. Because when you put x as k, it becomes k square by 2, and put it as 2, it's 4 by 2. Okay, it's k minus 2 over here. Yeah, we just have to solve this and find the value of k. You can go with the options, or you can simplify or do splitting the middle term, wherein obviously here it is 4 minus 3, which will give us minus 12. So k plus 4 is one of the factor and k minus 3 is the other factor. So we have two values of k, minus 4 and k is 3. But as we discussed in one of the previous questions, like it was 0 to 1 as a limit. In the same way, over here, because 2 is the lower limit, minus 4 cannot be the lower upper limit. Minus 4 is value smaller than 2, so it cannot be the upper limit. The upper limit has to be 3. So even if the option had minus 4, we were supposed to mark it as 3. Okay, so now to question 10, which is f dash x upon root fx. This is a direct formula. We'll just write it like root fx. If we write in the numerator, it is fx raised to minus half into f dash x. So going with the formula, it is fx raised to minus half plus 1 upon minus half plus 1. That makes it root fx upon half, which is, you can write it as 2 root fx. 2 root fx. That's the direct formula which we have been using in the previous questions. These questions are from the Gujcet papers. Okay, now to question 11, it is minus 1 to 1 of the trigonometric function. Now since both of them are having different degrees, odd degree and even degree, what we'll do is, and also we notice this is of the kind minus a to a. So we can check for a thing that whether the function is even or odd. If the function is even, the answer will be 2 times 0 to a fx dx for even function if fx is even. But if fx is odd, then the answer will be 0 straight away. Okay. So over here we know that sine is an odd function and its degree being cube, it is still going to remain odd, and cos is even, whatever the degree it is. So we have odd function and two even function, which will be odd, and so the answer is 0. And if you want to check, you can do this, that fx is equal to sine cube x into cos square x, and to check whether a function is even or odd, you have to replace x by minus x. So this becomes cos square of minus x. So minus sine cube, and cos being an even function, same, minus of fx. So when you have minus of fx, means it's an odd function. For an odd function, answer 0. Going on to the next question. Now we have e raised to a log x and e raised to x log x. So using the property, it is e raised to log x raised to a and e raised to log a raised to x. So we know that e and log are inverse functions. So since nothing is written here, it's the same base e, and so e and log are inverse function, it will get nullified. It's x raised to a and a raised to x. Now what's the integration of x raised to a? It is like x raised to n, x raised to a plus 1 upon a plus 1. And what is the integration of a raised to x? A raised to x upon log a and a plus c. Question 14 now. And if you see, this is a question of sine cos, and limits are 0 to pi by 2. These are some questions of the kind wherein we have 0 to a of whatever the function, and if you apply this, that is 0 to a of f of a minus x, the missing term from the denominator will be obtained here. Let's do it, and then we will see how to do without all the steps directly. So first I'm going to apply pi by 2 minus x wherever there is x. And denominator also comes out to be in the same way, 2 by 3 pi by 2 minus x plus cos So when we apply pi by 2 minus x, it becomes cos, sine gets converted to cos because it's 90 degrees, same down here. But the denominator doesn't change because the first term becomes cos and the second term becomes sine, and finally it remains the same. When the denominator remains same and the numerator will become the second term, like sine was already there, now it became cos, then we should add the two integrals. On adding, what will you get? Since the denominator is same, numerator will become sine raised to 2 by 3x plus cos raised to 2 by 3x. It's going to get cancelled, dx. So put the limit, integration of 1 dx is x, and then you put the limit, it is pi by 2 minus 0. That's pi by 2. That's 2i value. So I is pi by 4. So in such questions, you can put a direct method, that is, you can use b minus a upon n. So if you are taking so in such questions, you can take b minus a by 2 if we are taking the limits as a to b, because this is applicable for such questions where we have a to b dx. Now in this case, our b is a and a is 0, so it will become, or we'll just write from here, it's pi by 2 minus 0 upon 2, that is pi by 4. If you observe the question and you notice, okay, on applying a plus b minus x, if it is a to b fx, then we are going to apply a plus b minus x, f of a plus b minus x. So if we apply a plus b minus x, or if it is 0 to a and you apply a minus x and you notice that the second term is going to come, then you can do this straight away, b minus a by 2 it is. Okay, so we have a similar question here. If you notice, if we write this limits, it is 1 by n, a minus 1 by n, when you separate this up. And that means if we are going to add, if I'm going to write capital A is 1 by n, the lower limit, and capital B is this, and we find A plus B minus x instead of x. If we're going to write this, let's see what's going to happen. So we have A minus x. That means now when we are going to apply this value, this A plus B minus x property here, this is going to become A minus x, and we will have the second term up. It's already root x is there. Now we'll get root of A minus x. So you can put it directly. That is B minus A upon 2. Upper limit minus lower limit upon 2. That is A minus 2 by n. And if we want one of the options here, we need to take LCM, and this is going to be options. And if you do the long regular method, it will turn out to be 1 upon n, A minus this. Instead of x, we will write A plus B minus x. That is going to become, and here also we will write A minus x, wherever x, A minus x dx. I should have written dx here also. Okay, 1 upon n, A minus 1 upon n, root of A minus x upon root x. See, it is the same. Now when this becomes, this we denote as I, and this is also I, and when we add it, it is going to become 2i is equal to root x plus root of this upon the same. So it is integration 1 dx with the limits. And so integration of 1 is x. So we have A minus 1 upon n minus 1 upon n, and I is A minus 2 by n upon 2, because that was 2i. It's the same thing. You take LCM, you get option C. So for such questions, if you can realize, and yes, with practice you will, then you have to use the formula, shortcut method, B minus A by 2. B minus A means upper limit minus lower limit, upper limit minus lower limit upon 2. That's the shortcut formula. You can use the shortcut formula, that is upper limit upper limit minus lower limit upon 2. Whatever is the upper limit, whether you call it integration A to B, then it's going to be B minus A upon 2. So we have done a few questions. Few more questions I will upload in the next video. Keep watching. If you have any more chapters to be taken up, you can just comment in the box. I'll take up those chapters. Do like, subscribe, and share the video. Thank you.